Welcome to the revision for paper 1. So today we'll be focusing on factorization algebra factorization. So we're going to look at all the concepts that cover factorizations, all type of questions for factorization. Fine. Factorizing of algebraic expressions. So for the first one, we're going to look at commonly highest common factor, difference of two squares, quadratic trinomials, grouping, as well as sum of difference of two cubes. So basically what you need to understand about factorizing, if for example, I have 3 exponent, not exponents, I can say 3x plus 4x squared, x squared. This is an example of taking out of a common factor. So a common factor right here, it's x, then into x, 3 plus 4x, 4x. Fine, and this is a form of factorizing. This is factorizing. This is factorizing. And then if I multiply this, if I say 3 exponent x plus 4 exponent x squared, I'm simplifying, so it's taking me back here, right? So this is simplifying. So factorizing is basically the reverse of simplifying. So instead of simplifying, if you're not simplifying and working in reverse, you're factorizing. So we're gonna look at the first one, taking out of a common factor. Taking out of a common factor is the same as dividing. Yeah? We're gonna look at this example. If I say, what is the common factor? A factor, it's a number that goes into another number without leaving a remainder, right? So we pick the highest common factor. That is what we work with, highest common factor. So the highest common factor of 12 and 18, it's 6. It's 6. And then the highest common factor of x cubed and x squared, it's x squared. X squared. So you're gonna have 6x squared. When you're taking out a common factor, you act as if you are dividing. So if I divide x cubed with 6x squared, this is gonna cancel that. So I'm gonna have a single x, and then 12 divided by 6, it's 2x. That's what I'm gonna have. So I'm gonna have here 2x, and then minus 18 divided by 6, it's 3. And then x squared divided by x squared is still x squared. So this is my final answer. So sometimes, not sometimes, every time I need to check if my answers are correct. How do I check? I check by multiplying out. So if I got this, this is how I check. I just do this on the side. I say 6x multiplies 2x. So I'm going to have 12x cubed minus 6x squared times 3. It's 18x squared. So after doing this on the side, I can see that it takes me back here. So this means that this answer is correct. Sharp. Then we're gonna look at the second one. Gonna look at the second one. On the second one, you're dealing with a bracket. You're dealing with a bracket. In this one, you were taking out a term which was 6x squared. So in this case, you're dealing with brackets. Remember, there's a difference. If I have a plus b, generally these are two terms, right? But the minute I say a plus b inside a bracket, this becomes a single term. They make one term because they're in the bracket. But if they're separate like these, they are two. But if they're in a bracket, they make one term. So we're gonna look at the first one, the second part. So in the second part, we have 2 of the x minus y. So I take it out as a common factor. So I'm gonna have x minus y because there's x minus y in the first term as well as the second term. So this is going to be x minus y. Then minus, I have negative 3 remaining. So remember I said we divide. So if I divide x squared, xy all squared with x minus y, it's going to cancel out a single one. So I'm going to remain with only a single x minus y. That is my answer. That is what you see there. Yeah, sharp. So if you're going to look at uh, 3y, negative 3y, negative 3y, I'm going to have negative 3y, negative 3y, negative 3y, 3 into x minus y. It's this term. So I divided by xy. I'm doing this on the side, remember. So it means this is going to cancel out this. So I'll only remain with negative 3. So if I'm going to calculate this, xy times xy is going to give me xy all squared. I don't need to multiply it out. I don't need to multiply it out. If I have a times a minus b into multiplying a minus b. If I have something like this is the same as a minus b all squared. All squared. Remember, it's one term and one term. Same thing as b times b, the same as b squared, right? It's just a matter of our illustration. Fine. So this is my final answer. This is my final answer. This is my final answer. So for taking out a common factor, importance is the highest common factor. Highest common factor, this was 6x squared. Then this is what we're left with. And then for brackets, you take out the bracket, you treat it as one term, and then divide term to get what is remaining. And then for number two, number two, we're gonna look at complex questions. Né? Let's say you have 3 terms. Let's say you have 3 terms. 3 terms here. 1, 2, 3. We're gonna look at what is common between 16, negative 8, as well as 36. As you can all see, these are factors of 8, right? So you can take out 8 as a common factor. So you're gonna write 8, and then you look at the variables. If you look at m has the highest of 4 exponents. Then there's 3, then we have 2. So we're gonna take what is common. So 2 exists in all of these. 2 is a factor here. There's 2, and then 3 has 2 also. So you're gonna say m squared, m squared. Then after, we check out um n, n 8 for 16. Then you have n exponent 7, then n exponent 3. Don't got the 1 exponent 3 because you're a common. You pair go fail. So over the bracket, then you know that 16 divided by 8 is 2. And then m, you're gonna have m exponent 2 because 2 times 2 gives you 4. Then you have n, then you have 3. Sorry, for m, not 2 times 2, but 2 plus 2. Then for n, you have 8. So it means you're going to have 5. In order for you to get 8, you need, from 3, you need 5. Then minus this 8, negative 8 divided by 8, it's a negative 1. Right? And then m, you need a single m. And then for the n, you need 4 n's to get 7. Then plus 36 divided by 8. Can I have 8, 16, 24, and then